KCC105 for week number 4. We're going to talk about regression lines. Thanks for putting in your numbers for the coin flip data. We are going to see how that relates to linear growth. So week number 1, we were talking about each and every hour. If we have something like that where a constant change and the graphs look like this, everything is nice and uniform, we can talk about linear growth. But that coin flip data, and here's the graph that you all produced. Thank you for your data. You can see there's a pattern, but it's not perfect. It's not uniform. So each time the numbers are changing a little bit differently. There's some zigzags. There's different rates of change. How do we deal with this? When we have data like this, let's face it, this is real world data that's not perfectly changing. We need to fit that data, the random data, with a straight line like this. And that line is called a regression line. And that's what we're going to get at right here. Trend line is another name for it. And I'll show you 2 different ways to make it using a spreadsheet. And that's our goal, is to get one of those, and then we can find a formula. Because if you have a formula for a regression line, then we can talk about the rate of change. So how are we going to do it? Well, to get that formula, to get this formula right here, those numbers for this regression line, this trend line, you can use a formula. Oh, shit, no thanks. We're not going to do that. Guess what? We can use a spreadsheet. I like a spreadsheet. Technology is going to make our job easier. Let's look how to do that. And that's what your homework, your assignment is going to be. So looking at a spreadsheet, first of all, Google Docs. Everybody has access to this through your Kindle email. If you have a Google Doc and you have data like your coin flip data, you can highlight the data right here. Highlight both sets of data. If you just pick one set of numbers, not working. Highlight both sets of data. Go up top, insert, chart, and ta-da. Well, okay. It gives you a graph. That's good, but it doesn't give me the trend line, that equation. You got to dig around just a little bit. Over here, there's some options. Customize, series, and down here, there's a little box for trend line. All right. It gives me the trend line. I'm so close now. I got the trend line, but I don't have the equation. So down here, I believe is label. Yeah, label. Click that, use equation, and there we go. It gives me the equation right down here in the corner. I like it. Not so bad. Apparently I missed some. That equation's a little different than what I had earlier. Either way, this is the process. If you have some data, highlight data, insert, get yourself a graph, and then go over to customize. You get the series. We can make a trend line, and we can label it with our equation. That equation puts us in the driver's seat, so to speak. So now that we have a data, imperfect real-world data, we have an equation. This equation is different than what I just showed you, but we're going to use it for this video. We got an equation. What does it mean? Well, that first number in the back here, the number in the back of the trend line, the regression line, that's called an intercept or the starting point. It says I'm starting at about 0.3. And look at this, the graph. It almost starts at 0. That number is almost 0. Okay, that kind of makes sense. That number in front of the X, this is the critical one. We're talking about linear growth. Every hour, what do I earn? That number is the slope or the rate of change, and that means rate of change is every year each. So what's it mean? What's it mean? What is this? Coin flips. Coin flip means, oh, every time I flip the coin, I get 0.499 heads. Well, that sort of makes sense, but coin flips, we think more in terms of percentages. So you could say every time I flip the coin, I get 49.9% chance of heads. Well, it rounds up to 50. Guess what? That makes sense. So look at this. We did some kind of abstract mathematics, and it goes back to common sense. So you might say, yeah, well, why'd I have to do this? But don't worry about that. Think about the connection. Something you know is true. Yeah, flip a coin, 50%. We're reflecting that in the real world data. That's kind of neat. That's kind of neat. You can give me imperfect data, and then we go through this process, and it gives me a number that makes sense. So we're going to see this in another example. Well, your week 4 assignment is going to make another example of this. We're not talking about coin flips. You're going to find time sequenced data for your week 4 assignment. So anything that you gets measured every day, every week, every year, so forth. And quantitative, of course, we're talking about numbers. So you're going to find a measurement every week, every day, every year. So think about where you could get numbers like this. Population, for instance. Here's the population of Chicago, and I'm going to use this in this example in just one moment. Height, if we're talking about measuring somebody every year, something like that. Money. Obviously a classic example. How's the business doing over time? So let's get to the spreadsheet, and I'm going to show you an example using the population of Chicago. This is time sequence data. Every 10 years, I have data. Whoa, that is not what I wanted. Forgive me for that. Every 10 years, we have the data, and we have the quantitative data. Can we make a regression line like before? I'm using Excel here. If you like Google Sheets before, you can use that. If you like Excel, that's going to work too. One thing I'm going to do, I'm just going to clean off all the numbers before 1900. I'm just going to use these numbers. And here's the other thing I'm going to do. When you do regression lines, get rid of the numbers, and I'm going to start at 0. That just is going to make things a little easier in the end. And instead of the next one being 1, I'm going to go 10 because I'm jumping by 10 years. So you see, all I'm doing is I'm getting rid of the 1910, 1920, and I'm just putting 10, 20, 30, 40, 50, 60, and so on. Okay, with this data, how do I grade the regression line? Very similar to what I did in Google Sheets. Highlight the data. Insert up top, and then over here they have lots of different graphs. Click the little dots. I want a scatter plot, and you see, whoa, it's sort of like a line, but then it comes back down. This might get a little tricky. All right, how do I get a line? Hit the plus button here. Oh, look at that. I want a trend line, and you can see it's not too perfect. And then over in the corner here, and they say more options, because I've got the line, but I don't have the equation. So you look through here. I want the linear one, and let's see, where is it? Where's it say equation? Display equation on the charts, right in my face. I'm missing it. Okay, I've got a graph right here. Is it perfect? No, it's not. And some of you who might have more math might be saying, well, why don't you go down here and you can change the type of trend line? Yeah, we can do some crazy math. We're not doing crazy math. Get a linear trend line. Let's look at this equation, and let's try and make some sense of it. So if you have a trend line like this, and you've got an equation, but it doesn't quite match up, well, we can try and interpret it. We can say that number right here is the intercept of the starting point. It means I'm starting at 3E06. Wait, that's math language. The E really means just put 6 zeros afterwards. So it says I'm starting at 3 million. Is that accurate? Not really. This regression line is not too perfect here. What's that number up in front mean? It means the slope. It means rate of change. It means every, and I'm measuring 10 years. So every 10 years, the population changes about 5,500 people. That doesn't seem like too much for a big city like Chicago. So once again, that I use the word about because it's not perfect, but really what I'm seeing is I'm seeing things not really working perfectly. So what's that mean? It means if I'm looking at data like this that is just not lining up on the line, I'm going to say I have a weak correlation. You can always find the line, but then you might have to say, you know what, this one's kind of a weak correlation. And I'm going to say it's not useful for observations or predictions. Here's an example that's the vice versa. If I look at the Google stock price at the end of last year, you can see that it's, other than like one little bump, it's really following a line pretty well. So that means I have a strong correlation. It means I can use it for predictions. It means that if I said, well, predicted in this month, February 2018, I can take the equation. I can look at 2006. That's when I started. So that's 0. Remember, you always start at 0 and you kind of go down the line from there. And so this month would be 15. I can take that number 15 and I can plug it in to the equation. So if I take 15, I take the equation, plug it in. Now we got to do a little bit of math, but you take your pocket calculator. This is nothing too advanced. I take my calculator, I multiply, and I get a number. Okay, and so that number, that is my prediction. I say I'm going to predict that's what the stock price is in February 2018. I didn't use 2018 in the equation. I got to use the 0, 1, 2, 3 because I got to think each month is one value. Now, one other thing, when I say predict, make sure you specify how. Don't just say, oh, I predict here's what the stock price is going to be. How did I get it? I got it based on past performance. You can use these sort of language according to earlier trends in the data. So that's what's going to get me. This would be a good answer for potentially if you're making a prediction. Say, based on previous performance, I'm thinking the stock price is going to be $1,073 in this month. Go ahead and check. See how I did on the prediction. Regression lines. I don't care if you're using Google Sheets, if you're using Microsoft Excel and using the predictions, but that's going to be a central part of the week 4 assignment. Follow through these steps. A lot of stuff going on. And if you do have questions, please reach out. I'm happy to work with you to get an understanding of this process.